Hello Legacy Savers. Today we're going to look at using graphs to relate two quantities. Your learning goals for this particular video. I can identify a variable at quantities based on graphs, and I can describe relationships between the variables, and also that you can sketch a graph based on a real life problem. So basically what these are looking at is we're going to actually have a graph. It's going to be a bunch of lines. Not going to be a straight line, but it's probably going to be a little different lines because this is real life problems. So I have this graph here, and it shows the volume of my air in a balloon as you blow it up until it pops. So the very first thing we need to figure out, what are our variables? So the first thing you're going to want to look on a graph is the words around the edges. So these are the two words around the edges. Those are our variables. So I know my variables are volume and time. Those are my two variables. Describe how the variables are related at various points on the graph. So it looks like from right here to right here, so as time goes on, looks like the volume in my balloon is going up. So like the volume of the air. So it looks like right here I'm blowing into my balloon, right? And then it looks like I'm taking a breath right here. Wherever I have a straight line is where I'm breathing in. And then it looks like right here again we're going to blow back into the air, or blow back into the balloon. Looks like I need to take a breath there for a little bit. Blow again. Breath. And then I start going up, blowing, and this is when the balloon pops. Now, notice how it's a straight line going down, because at time, whatever time that is, it actually just blows up. So my volume is 0. So I have to show that at that time my volume went straight down to 0. That's why we have a straight vertical line right there. Let's go to the next one. So on this one I need to find my variables. So we're going to look on the two axes. Well, it looks like one of our variables is length. So my variables are length, and it looks like the other one's time, right? Now, we're talking about board length, so we can all assume this is like a board of wood. And as it's going down, it looks like as time goes, it looks like my length went down at a certain point, like right here, right? And it keeps happening. So one assumes I'm cutting this board in pieces, right? So right here where it goes down, that's where I'm cutting. That's where I actually made the cut. And then it looks like it stays that length for a little while, and then it's cut the board again. And it looks like right here I cut the board again. So for every time you see that vertical drop, it's because my length went down, because each time the vertical drop, that's when I've made the cut and I cut through the board fully. The straight parts, the horizontal parts right here, those might be when I'm actually sawing the board apart. That's why you don't see it happen all the time. It's because I have to either A, put down the circular saw, or I have to be using my hand saw to cut the board apart. Now, what if I'm given a table and then I need to figure out the graph that represents it? So let's look here. A band allowed fans to download its new video from its new website. The table shows the number of downloads after 1, 2, and 3, and 4 days. Which graph could represent the data shown in the table? So it looks at day 1, I had 346 total downloads. Day 2 was 1,011 downloads, 3 was 3,455, and 4 was 10,426. So let's kind of look at a process of elimination, right? Well, it looks like this went down, right? And that's not what happened. It looked like we went up, right? We're going up by quite a bit. So we know it can't be D. Now let's kind of look here. How many did we go up by each time it moved? So it looks like from here to here we went up by 665 new downloads, and then the next point we went up by 2,444 downloads, and then it looks like we made a really big jump and we went up by 6,971 downloads. So it looks like we didn't go up by a constant amount. And this one looks like it's like a pretty constant amount, right? Kind of this nice straight line. So we know it can't be A. And then if we look here, notice how C kind of starts to level off. Well, that's definitely not what it does. It slowly grows, right? Goes more and more each time it's left on there. So this one can't be it, because this one's just kind of starting to level off. You kind of trace, you would see it's starting to go like that. That's not what's happening. It's kind of doing this. It's going up and up and up and up based on the number of days. So I know my answer would have to be B. That would be the best representation of this data. Let's try it again. So I have this table that shows the amount of sunscreen left in a can based on the number of times I'm going to use it. So which graph could represent this? So let's see how much it changes each time. Well, it looks like this changed by 0.02, right? I went down, so I'm using like 0.02 of an ounce each time. Looks like this time I used the same amount, and same amount here, right? And this is only from one use, this is only one use, that's only one use. So it looks like I'm going up by a constant amount, right? Or not up, excuse me, but down. So this one kind of has a curve to it. Do you see how it's curved? So when you have a constant, it's going to look like a straight line. So it can't be B. And C, notice how it's kind of starting to make an upward trend, kind of, or just kind of level off. That's not going to happen, right? The amount of sunscreen I'm going to use, it's going to keep going downwards. But at the same time, this does kind of look straight. And if you look over here at this one, it says that this is the 4th data point, and I'm already at 0 amount of sunscreen, right? That's not the case. So I know it can't be A. So it's got to be C. C makes the most sense for my graph. It's not really going up. It looks like we're more going in a straight line, actually. So C has to be the best representation of my data. Let's try problem 5. So a model rocket rises quickly and then slows to a stop as its fuel burns out. It begins to fall quickly until the parachute opens after it falls slowly back to Earth. Which sketch of a graph could represent the height of the rocket during its flight? We're going to label too. So let's make a very large graph here. So we got time, and then we got height. There we go. So this model rocket's going to rise really quickly. So that means it's going to have a line with a high slope. And it starts to slow down as its fuel begins. So then it reaches the tip here, right? And it begins to fall really quickly, they say. So we're going to have a really straight line. But then the parachute opens. So we're going to get a nice gradual fall. Something like that, right? So this would be my first takeoff, right? So when we started to have this nicer curve, that's when my fuel stopped burning. So as the fuel runs out. And this is as it falls back to Earth without parachute. And then this is with parachute. So basically it's giving a representation of what would a graph look like depending on how things are put together. Basically that's what we're going to do as well. Relating quantities or two kinds of variables with a graph. And that's the end of this video. See you later, Savers.